lot of absentees today. Just want to do a very quick check-in. How many of you are still very confused about differentiation? How many of you are still confused about differentiation? Do I take the? How many of you are not confused about differentiation? Okay. So I guess those not raising hands will mean that you are still a little bit confused. Okay. Because yesterday I was having consultation with some of the classmates. And then my gathering was that you're still a little bit confused. Okay, I thought that since our WA is tomorrow, okay, I just want to really reinforce certain ideas about differentiation first before I continue with quotient rule. Okay. Okay, so let's do a quick recap of power rule first. Okay, so power rule essentially, we're looking at things like maybe y equals to kx to the power of n. Okay, we differentiate with respect to x, so dy over dx. K is the constant, n we bring down, then after that the power we minus 1. Okay. So that is how we apply our power rule. Then after that we have also learned our chain rule. Whereby, for example, okay, for example, if I have y equals to 2x cubed plus 4x plus 1 to the power of 6. So we have an expression that's to the power of 6. Whereas over here I just have one variable only. So take note that you must have your dy over dx. 6. Bring down. Keep the base the same. Power minus 1. Then we differentiate the inside according to our power rule. So we will have 6x squared plus 4. Okay? You can leave your answer in this manner. Okay, sorry, cannot. Just this one need to simplify it. So you can leave your answer like that if you want to. Okay, that's for your chain rule. Alright? And then for product rule so far, we are looking at two things multiplying to each other. So let's say our 2x squared minus 5x to the power of 7, and then x plus 3x plus 3 then. Okay, to the power of 2. So instead of expanding everything to differentiate, we learned that in our product rule, we can keep our left side first, differentiate the right side using our chain rule. Okay, so this is the derivative of the right side. Then after that, plus keep the right side, differentiate the left side. And then we walk into simplification. So I'm not going to do a simplification process. Okay, just want to recap about the different rules itself. Okay, I think a very big part that we need to understand about differentiation is one of these very common application, which is linked to gradient. Okay, so I noticed that even from your quiz itself, okay, yesterday, when I returned it to you, okay, many of you have difficulty in interpreting the gradient part. Okay, usually we are always given a curve. Okay, there might not be a diagram given to us. Alright? Then they tell you that at a certain point there is a tangent. Oops, very bad tangent. tangent over here. And then I want to find out what is the gradient. Okay, the gradient will be the dy over dx of the curve. So y equals to something. Okay, so the gradient will be your dy over dx into this over here. Okay, and then we will substitute the point, the x coordinate of the point here into the dy over dx in order for us to find out the gradient. Okay, so in summary, there are the things that we need to take note of. Okay, when it comes to your differentiation, you need to be able to link dy over dx to the concept of gradient itself. Okay, this is a very important thing because otherwise, okay, when we move on to chapter 13, okay, we are going to diving into all the tangent normals and all that kind of stuff. Okay, a lot of other applications about dy over dx. Okay, and then also one of the classmates yesterday asked me what is derivative. Okay, derivative is the result that you get after differentiation. Okay, just like you multiply things together, okay, you will get the product. Okay, so derivative is the word to use. Okay, when you the word to use to describe the end result. Okay, after differentiation. Alright. So in this, that's your differentiation that we have covered so far. Today we're going to your quotient rule. So I'll start here today. So yesterday I asked you to go back home and dream about the quotient rule. Not sure whether you have. But essentially for quotient rule, we're looking at things that start off as being a fraction. Okay? Then our dy over dx, okay, will go by a certain chant. Okay, so you can go and start chanting it. We keep the bottom, differentiate the top. Okay, multiplying these two together. Minus away, keep the top, differentiate the bottom. I use the apostrophe to denote the idea of differentiation. And then after that, we divide by bottom square. It must go in this manner. Must be keep bottom first, then differentiate the top. Then minus keep top, differentiate the bottom. Okay, we always start with the bottom, keeping the bottom first. It cannot be the other way around. Because this is a minus, we very well know that 5 minus 2 is different from 2 minus 5. This is 3, this is negative 3. So they are not equal. Okay, so likewise, this one must also follow in that format. Okay, to reinforce is, okay, to reinforce what we did yesterday, I went through try 9 already, so let's take a look at try 10. Okay, I'm writing it in short form. WRT means with respect to. Okay, so we want to differentiate square root 2x minus 1 with respect to x. Okay, so we will start off with letting y equals to square root 2x minus 1. That is 2x minus 1 to the power of what? Decision? 2x minus 1 to the power of what? Half. Is it? Okay, yes. So to the power of half. That means that your dy over dx in this case will be bring down the half, 2x minus 1 to the power of half minus 1. Okay, then 2x minus 1 we need to differentiate and we just get it 2. Alright, then half times 2 will give us 1. So you'll be left with your 2x minus 1 to the power of negative half. In other words, it is the same thing as this. Okay. 2x minus 1, and we have something that we need to end up arriving at. Okay, we need to show this. Okay, so using our quotient rule, okay, we will keep the bottom, which is square root 2x minus 1, differentiate the top 1 minus x, so we get negative 1. Okay, then minus away, keep the top, differentiate the bottom. When we differentiate the bottom, we are differentiating square root 2x minus 1 only, which we have already done so in part I. Okay, and this is what we have, right? You may want to write it in either this form or this form, okay, but to keep things neat, I'll just use the 2x minus 1 to the power of negative half form. Okay, then we divide by the square of the denominator. Okay. We go into simplification now. Right, so this is square root 2x minus 1 times negative 1. So we have negative square root 2x minus 1. Okay. Minus away. In this case, okay, depending on what's your choice over here, okay, you may want to write it into a fraction. Like that also can. Okay, that will be helpful for us later on. Okay, divide by square root 2x minus 1 square. That means that the square root disappears. We only left with 2x minus 1. Okay. Okay, I want to show one method to you first before I show you another method in terms of simplification. Okay. Notice that at this juncture, I turned this into a fraction already. Okay. This means that it is as good as writing 1 minus x over square root 2x minus 1 in the denominator. Then over 2x minus 1. Okay, we're handling multi-layered fraction over here. Do make sure that your fraction lines are long enough. It covers the things that needs to be covered. Okay? I noticed that some people like to draw their fraction line halfway. Then know that your marks will also be probably halfway. Okay. Then let's work with the numerator. Don't forget the denominator still exists. We work with the numerator. Okay. So in this case, this is not a fraction. This is a fraction. If I want to create a common base, okay, we're going to have same denominator first by multiplying the left side with square root 2x minus 1. So in other words, our original square root 2x minus 1 will multiply with an additional 2x minus 1 square root. Then minus away. Keep in mind there must be brackets for my original 1 minus x in order to keep everything the same base. Okay. So this is the numerator. The denominator is by 2x minus 1. Okay. I'm working on the numerator. So this is the numerator. Okay. Then square root and square root, they are the same inside, so it becomes our 2x minus 1. Not forgetting there must be brackets because there's a negative sign outside. Minus away 1 plus x over square root 2x minus 1 over 2x minus 1. Okay? fraction, right, I want us to be able to realize something. Okay, imagine it in numbers. Okay, that it is half divided by 7. Okay, so we have a fraction in the numerator divided by 7 as a denominator. This is the same idea as half divided by 7, I guess. Whereby in numeric form, we know that it is half times 1 over 7. Okay, as in if I do a keep flip change lah. Okay, so divided by 7 is the same as times 1 over 7. Which essentially is the same as numerator times numerator, denominator times denominator. Okay, so what am I trying to drive at over here? I'm trying to drive at the fact that if I write it this way, I can arrive at this idea whereby the denominator can multiply with each other. Okay, so that means that I can take this fraction into just our usual 2 layers as just square root 2x minus 1 multiply with 2x minus 1. Okay? So what I'm doing is multiply these two. Because of how fractions work. Okay? Then continue to simplify. So numerator minus 2x plus 1 minus 1 plus x over, this is power half, this is power 1, it is the same as 2x minus 1 half plus 1 in its power. Wait, we don't need to do that, right? Because this is our objective. Okay, then we arrive at our final answer, which is negative x over 2x minus 1 square root 2x minus 1. Okay. I hope that you're able to follow through in terms of my simplification. Josh, I sincerely hope that you are dreaming about quotient rule. Otherwise, could you please wake yourself up? Thank you. Okay, any questions for this simplification process? Should I show you another method? Okay. The reason why I want to show another method, okay, in terms of simplification, is because I do notice some of you are doing this when it was in your quiz itself, when you chose to do quotient rule. Okay, and then also the way you do your product rule simplification. Okay. I'll let you decide. Okay, I want to show you the two methods, so I'll let you decide, okay, what is better for you. Okay. Right? The other method continues from here, okay, whereby I choose this 2x minus 1 to the power negative half instead of writing as a fraction over here. Okay. The next process is to simplify the numerator. And in terms of simplification, we want to factorize out, okay, things that are in common in the numerator first. Okay. When we factorize, okay, let's say I have 4x minus 6x squared. Okay, maybe not 6x squared. Okay, maybe 8x squared. I will factorize out between my 4 and 8. I will factorize out a 4, right? Okay, which is the smaller of the two numbers. Agree? Okay, and then my x and x squared, I will factorize out a x because x to the power 1 is the smaller of the two x's. Agree? Then after that, I will have 1 minus 2x left inside my brackets. That's how we do factorization, right? Okay, so if I want to apply my factorization idea to this, okay, this square root 2x minus 1 is as good as writing to the power of half. We notice that there's 2x minus 1 over here and the 2x minus 1 over here. Okay, so out of the two, we pick the smallest one. So between power half and negative half will be smaller, so we factorize out negative half. Agree? Okay, so that means 2x minus 1 to power negative half is taken out. Okay, so this will be challenging in terms of your indices laws, yeah? Okay, now, since I have taken out 2x minus 1 to the power negative half already, we will now need to write down, okay, what are the things left over inside my square brackets here. Okay, so this 2x minus 1 to the power of half, I took out a negative half. How many 2x minus 1 will I be left? How many? What's the power of 2x minus 1 over here? Should be a 1. Okay? If you don't know, you can work backwards one. So this one times this one, if I expand, it will be negative half times 1. Okay? So, sorry, negative half plus 1. Alright, that will give us a half. Okay? Our indices law. Okay? This thing times this thing, our power will add together. Negative half plus 1 does give us a half. Alright? So, this one is what is there. Then after we have negative 1. Okay, that's remaining. Minus away 1 minus x. Because I have already taken this out. Okay? Then after that I divide by 2x minus 1. This out. Okay? So if you ask me for a personal preference, I usually don't like to do this. I prefer to do this. Okay? But that's really just my personal preference. Alright? I leave it to you to choose and decide. So from here onwards, what we do next, okay, is that let's simplify the things inside the square brackets first. So 2x minus 1 times negative 1, we have 2x plus 1 minus 1 plus x. Then denominator is 2x minus 1. This one is power negative half. Negative means that this thing can bring down to the denominator. So 2x minus 1 to the power of half times 2x minus 1. Okay, then we have negative x over 2x minus 1 square root 2x minus 1. Okay, so that's how we show it. You may think that this method seems like it is easier because the process is shorter. Okay, but I also hope that you realize that my method here is long because I made it very clear step by step, okay, for you to understand. If you're able to understand things already like this one, okay, from here you could skip all the way to here already. Okay? So I leave it up to you. Okay, what is it that you prefer? You prefer to handle fractions or will you prefer to handle it in indices? Okay, because I think you know your own strengths better, alright, what will actually work out better for you. Once you decide on something, make sure you just continue using the same method. Okay, don't flip-flop, go through different methods all the time. Okay, and then you'll be all over the place. Just decide on one. Fractions, otherwise factorize. Okay? Any questions? Alright? Okay, if no questions, by the way, this kind of question for quotient rule very common. Okay, when they ask you to differentiate the denominator is in square root form. In fact, I think last year, was it N level or O level? Yes, was like this one to the power of 5 over 2 or something like that. Yeah, which was definitely more challenging. This is to the power of half, right? The denominator. They gave last year to the power of 5 over 2. Okay, so do expect such things to be common okay, when it comes to differentiation using a quotient rule. Alright? If no questions, okay, I want you to practice, okay, to practice the quotient rule. Exercise 12.4.